And we're live.
Hello, everyone. Welcome to another edition of the Moonbuilders Workshop. We're so happy to have you here. This is a technical workshop series that's created by developers, and it's created for developers, and it's organized each month by Jimena from the Moonbeam team. If you're joining us for the first time, Moonbeam is an Ethereum-compatible smart contract platform on Polkadot, and it makes it easy to build natively interoperable applications. Our focus has been on providing the most seamless experience for ETH devs and to provide the easiest on-ramp and the gateway, to the Polkadot ecosystem. My name is Kevin Nielsen, and I'm a developer relations engineer at Moonbeam. And today I have the distinct pleasure of introducing Massimo Lurashki, developer advocate at Subsquid. Subsquid is an on-chain data processing solution that enables Web3 builders to gain access to on-chain data on their own terms. So Subsquid features multi-layer architecture and decentralized governance, and Subsquid is the most developer-friendly and resource-efficient way to build, test, and deploy customized APIs for all blockchain-facing applications. They support a number of different networks. I believe it's something like 33 in total. And Massimo, in terms of his background, he studied chemistry in high school, but he was too interested in computers. So he ended up getting a master's degree in information engineering at the Polytechnic of Milan. And then he found a love for data engineering. And Massimo's been involved in the blockchain space since 2017, and he joined Subsquid last December. So just a couple of logistics items. We have a ask a question box. Please feel free to ask your question anytime, and we will get to it, at some point or towards the end as well. You can also leave comments and participate, and let us know, if you have any questions or we want to get everybody involved. So with that, I'll go ahead and hand it over to you, Massimo.
Yeah, thank you for the introduction. You basically cover all the major points. I don't need the presentation anymore. But yeah, like you said it 100% correct. I think that some of the key points that we can make with this presentation is that the fact that as Moonbeam wants to remove barriers to onboard developers into the Polkadot ecosystem, we want to remove barriers for data engineer and data analysts to profit from all of the like insane amounts of data that is going to be like stored in blockchains essentially. As the presentation title says, we are going to build with this presentation a unified API for indexing EVM and substrate data with Subsquid. This is important for us because it's one of the major features and functionality that we Subsquid as a project provide, as we kind of like pride ourselves to be built for developers, by developers, for developers, and make sure that they can have all of the possibilities open to them. We're going to see it in a few seconds, but you already touched on this. Who am I? I am a developer advocate at Subsquid. You can find all of the social media links in here, and the slide deck is in the chat as well. Diving deep into why Subsquid, as the meme says, the demand for blockchain data is too damn high. So there's going to be a lot of problems there already are, but it's only going to grow in the future for the demand for project to have access to data and to perform data analysis and make informed decision is key. And the tools are not that great, not until recently, I think. And we try to put a stop to that, essentially. I think you had a couple of questions, Kevin, as to, well, go ahead, sorry.
Yeah, certainly. So just, the first one is, what's the difference between Subsquid and other data solutions?
Yeah, and this, apart from the title of the presentation itself and the workshop, like we are the only one that can actually fully allow developers to index both Substrate entities and EVM logs into one single project. We think that the main differentiator between us and other similar solution is the architecture. Here we have a representation of what other typical solution propose, which is a monolith architecture. This is sort of bad in our opinion because it makes it so that first of all, there's duplicated data. Every single API has to index the data on their own. It creates large amounts of duplicated data. It's not performant because every time you make a small change to your project, you have to wait for reindexing. If you don't do this, then if you don't, it relies on slow gRPC calls because your project is directly connected to the blockchain. So that's the only way to query that you have. And it's not resilient to runtime upgrades, which is a great feature of Polkadot, but it also is quite a headache for developers because every time a change is introduced, you have to adapt your API, and you have to make sure that your API is also backwards compatible. What we propose, yeah, go ahead. Sorry.
Whenever we have like a runtime upgrade, it's always serious for the RPC providers to upgrade right away. And
Yep.
I totally understand there could be breaking changes, at certain points.
I have a couple of slides that actually demonstrate practically what it is, and we will see it during the development of the project itself. What is our solution for this? What we propose instead, the counter proposal instead of a monolith architecture is what we call a modular architecture. It's based on, as you mentioned, 2 layers. Developers typically only care about their business logic, and they can build lightweight, agile, and very easy to change and adapt because we allow for local development as well. Processors, what we call Squid or Squid API processor. Where one of the things we have not been great at is giving names to things. We're still deciding because we want to create an identity of Squid and Subsquid, but we have to find a good name actually. If there's a good suggestion for what people perceive as each entity, would be awesome. And instead, what we are pretty much set on is Squid archives. This is the foundational layer for our architecture, and those are the only ones that are directly connected to the blockchain. I mean, you can still go around them if you want to, but it's not required. It's another one. It's another great feature of the SDK because it gives you freedom to do pretty much whatever you want, but it provides you with a simple and linear way to get to your goal, which is have an API for your dApp. The reason why this is working well is because the archives pre-index raw on-chain data, and it basically divides it already into events, extrinsics, storage items, and in the case of Moonbeam and other EVM compatible chains, EVM logs, so that they are available to be queried via a GraphQL. Here in the middle, there's a GraphQL gateway. And so I don't have to go through slow gRPC calls. I can directly query the archive, and my Squid processor only cares about the already indexed and sort of filter data. And also I can do it in batch, which makes us faster in terms of block per second processing. Yeah, go ahead. Sorry, you had a question.
So you covered the difference between the archive and the Subsquid nodes, the Subsquid components. So who typically runs a Subsquid archive node?
Good question. Good point. Archive nodes are meant to be run by any infrastructure provider, which is interested in basically getting economical rewards. The idea is that for now we run them. When we're going fully live with the network, we're going to have a utility token that is going to make sure that infrastructure providers have an interest in maintaining the network. And this is also a very important point for us in the creation of a DAO and a decentralization network, because you cannot call Web3 is all about decentralization, right? But you cannot call it fully decentralized or really decentralized if every layer of that composes your product is actually decentralized. There's been lots of talks recently about projects going down because actually they are hosted on traditional cloud providers. This way, the hosting of an archive becomes it can be duplicated by multiple infrastructure providers, and I don't have to rely on only one data source.
For sure. That's awesome to hear.
Yeah, I mean, can skip up because I already talked about accidentally a few of this, but as I already said, the reason why this is gaining in performance is because the archives do the heavy lifting already, and the data is pre-filtered, and we can query in batches from the processors. It's like I said, it's pre-indexed and queryable, and by definition is faster than pure RPC calls. The other like big differentiator is that it's very permissive SDK. You can think of it as, I don't know, in the end, it's a Node.js project that is obviously augmented by packages created by ourselves. And what it allows, amongst the many things that you can do, is it's the only one that actually fully allows you to create a unified endpoint that indexes both Substrate and EVM data. The other great points that we can put forward is the fact that you have full control of the database schema. You can decide it by defining it with a GraphQL sort of dialect that we created. And it also allows you, like I mentioned earlier, you don't have to do direct gRPC queries, but if you want to, you can. In the same way, you can also fetch data from external APIs. Like you want to index the transfers of a certain token, and then you want to add the price of when that token when the transfer happens. You can do it. The price is not necessarily stored in the chain. You have to source it elsewhere, but you can. This is just an example, of course, but and last but not least, we provide the possibility of adding custom resolvers. If what is there is not enough, you can just extend it with however you want it. I mentioned it, but it's like I said, it's built for devs. Sorry, by devs. There's an easy setup. It starts with a template, which is already ready to go, and you can develop locally. You can fire up your own server, and good to go. We had a discussion this week about actually it was a project from the Moonbeam ecosystem that created its API in a day, because he said compared to other solutions, he was able to go through the trial and error process of developing on his laptop.
That's awesome to hear that this allows the fast iteration.
Exactly.
That's really, really cool.
And the same thing can be said for sync times. There's a lot of data stored in the blockchain, but it's because the archives pre-index it and pre-filter, you don't have to do it yourself on your project, on your API. You only have to do the syncing of the business logic that you have to do. So there's still a little bit of wait time, essentially, because of course you have to retrace the history of the blockchain, but you only have to apply the business logic that you define. You don't have to wait for like pure indexing of it. And we provide a serverless deployment service, so you can host your APIs with us. The last point I wanted to touch upon, and it's very important because, as you mentioned, there's a lot of annoyances when developing for runtime, and namely the runtime upgrades, for example. And our solution is to automate everything, so you don't have to do it manually. And you by definition, doing manually can be error prone. So if it's automated, we take that away. And also it's very boring. It's not necessarily what you sign up for doing when you want to build a dApp and you need an API. Exactly. So the idea is that you define your schema. For example, this is a GraphQL dialect that defines an owner entity. It's like this decorator here is to basically tell us that you want this to be stored in the database. Some types can be not entities, and that way they don't have a table on the database. And we go from this to this, which is a TypeScript class generated automatically that has all the necessary field that you defined, and like doing this on your own, obviously, it's a lot of boilerplate code that you don't necessarily want to do. The counter to the GraphQL schema, which is pretty self-explanatory and declarative. The same way I will, oops, yeah, no, it's right. The same way we treat runtime upgrades. So we have the automatic generation of Typesafe wrappers for Substrate entities generally. What happens is, let's take the example of a transfer, like a transfer event of the balances palette. It has gone through various changes throughout his life. And like, as you can see here, I think this was the introduction of a fee, and then it was taken away. So every time you would have to, yeah, you can see here as a fee. So every time you would have to see, it's basically at the version, at the block number XYZ, the version has changed, and this version introduced the fees. Now I have them, now I don't. So when you extract the data from the event, it's a nuisance. What we do instead, when we generate the class wrapper around the event, around the balances transfer event, we have these methods that are auxiliary essentially and help you extract the data contained in the event with the right with the right method, essentially, with the right in the right way. So in this case, instead of you can see that the return data is an array in this case, whereas starting from version 12.01, it becomes an object, for example. What else? We do that as well for the EVM. For EVM logs, what we do is, when you know you want to index a certain type of contract, you know the ABI of the contract, and what we do is we create Typesafe interfaces from it. Really quickly, I think this is exactly the ABI that we're going to use later in the example. It's ERC 721, and it defines, I mean, I don't know how much in detail we want to go with this, but let me find it. This is a function that is called approval, and it has these three inputs. Down below, I think we have what we really, the transfer one. What we do with this is we interpret it, we parse it, and we create this guy, which is an interface that represent the information contained in the event. And this is a cut short version, but an event mapping that allows, given a signature of an EVM event, the necessary function to decode it. Yeah, like, I think you had a question about where do people could start with the Subsquid if they want to. I think these resources are the best place to start with. We have documentation, which is a work in progress. For the time being, I took charge of doing the complete overhaul. I'm not saying it's perfect, but I would say there's some good highlights. Stuff that I've been told works best is, for example, the tutorial on how to create a simple squid, which goes from top to bottom. It's pretty much similar to what we're going to hear, just different type of project. And recently, in collaboration with you guys, there's also like a documentation page on Moonbeam docs about Subsquid. Like I mentioned,
that takes you through a full tutorial. It takes you through, the full.
Exactly.
Start to finish.
It's basically teaching people how to take the template, which is this link right here, and turn it into an EVM project. The template is, because we started with pure Substrate data, it only looks at that. But with this tutorial, you're gonna be able to turn it into an EVM project. Recently, luckily, they've launched a Stack Exchange for Substrate. And for any questions that you have, there's a Subsquid tag, or I think there's also an indexing tag as well. And we have a Telegram group and a Discord group. We're gonna make the Discord group more dev friendly and have a dedicated dev section. I think it's nice to sort of aggregate the entire community into one place, and maybe Telegram is too small of a place for all of the people that we hope to onboard.
Mm-hmm. And it's tough to find things in Telegram because things kind of get lost. And
Yeah, that's what I
organize
saw.
things.
Yeah,
Mhm.
that's what I
Don't
thought
forget,
as well.
Don't forget about the aquarium, right? The aquarium is super cool
That
to showcase.
yeah. Yeah, we're gonna actually at the end of the project, I hope to showcase the aquarium itself, because I have deployed my basically the finished project in there, so we can take a look at it. But the aquarium is what we call the hosting service. Essentially, when you're done with your project and you wanna, or you just wanna have a public endpoint and you're done with the local development, you can host it with us, and it's going to be publicly. You can decide if you want it to be publicly available or not, so people can, I don't know, look at your repository, inspect your code, take an example. If in general we are an open source community, so it'd be nice to do it.
For sure.
I think I'm pretty much done. Yes, we can start coding. At the end, this is what we are here for. I actually have updated the goal, so it's going to be a mix. So I initially started with an ERC 720 on tracker, but the steps are the same. The only difference is that given the title of the project, we're going to mix and match the indexing of Substrate events and also EVM logs. So we're going to maintain part of the template that we start with and add EVM indexing on top. So we're going to go through all of these steps: set up, reviewing the schema to add new stuff, generate models, generate the interface, like I mentioned. Then we have to implement new custom logic for the processor. You have to launch the database, because every processor has an attached database. And then because we have made changes to the schema, we're going to have to make changes to the database. Finally, launch the processor and profit. So maybe it's good if I start with, cloning the template. Like I said here, the only requisites are Node.js and Docker. We have I mentioned it multiple times, we have the template repository that can be used by people to have a starting point, which is what I'm going to do right now, and then we clone it. In order to do it, I don't know, let's say, random name. It can be, I could have left it as Subsquid template, essentially. It's going to be public. Let's go. Okay. Here we are. Now I'm going to shift to, oh, by the way, yeah. I'm going to shift to VS Code. And let's open it in a new window so it doesn't get confused. So what do we have here is, maybe it's nice to unpack what's in the project. We start with a schema, which is pretty simple in the case of the template. It only has accounts and historical balances. That's because the project in and of itself monitors the balances.transfer events. And I've already started. Yeah, go ahead.
Just one quick thing. Sorry, you mind zooming in just a little bit?
Yeah, I already zoomed in. I don't know how much is necessary.
That's
is this
awesome.
better?
That's amazing. Yeah, perfect.
Okay. Now I have a few issues with the. Oh yeah, I forgot. I have to install dependencies, of course. It's actually in the presentation, but yeah, there it is. Of course, it comes with like plethora of dependencies that we need to install. So that's what we're doing. But I'm already like looking into the processor, which is pretty much the core of the whole project. It's where you define your business logic, and it's where you're going to be working most of the times. Because the other two folders, types and models, are where automatically generated code goes. We have already automatically generated models from the schema that I mentioned. So we have the account model in here, and we have the historical balances model in here. In the same way, we have the balances transfer event that I think this one was the one I showed in the presentation. But we're going to have to redo part of it because this project looks into the Kusama network, and this is one of the things that we're going to change. We obviously are going to index Moonsama today. So this is done. Let's go back to the presentation. Sorry, I missed a step. Yeah, so we installed the dependencies, and then we need to install a couple more because, like I mentioned, the project is not a natively EVM. We have to install these other Subsquid dependencies. So let's do it. Actually, let me close this one, and this is the interesting window. Couple of boring passages. I apologize for the wait, but it's necessary. In the meantime, let's move on to the next slide, which is the schema. Because we're going to look at the ERC 721 tokens, we want to represent those that information with these entities. We're going to actually change the account entity to an owner, just because it was the original project had these, so I didn't bother changing them. Anyway, like we want tokens, owners, the contract, and we're going to keep transfer and historical balance. So let's copy. Oops. Bummer. I cannot multiple select. And I'm going to open this Graphql schema, copy paste it. It realized that I didn't change this guy because, well, I didn't. And the rest is actually pretty much new stuff. Like I said, I changed the account to be owner, but I kept the reference to historical balances. So whenever I encounter a transfer, I'm going to create one of these entities, which is going to basically snapshot the balance at that time. And the owner will have an array essentially of every time the balance has changed in his history. I think, yeah, it says account. So it's correct. Great, cool. Now I need to run a command to generate the models, like I mentioned a few times. This is going to be, as we can see here, it made a couple of changes to the historical balances model. Can't remember why, but most importantly, it had removed the account and generate these 3 new models for us. We can take a look at it. I think I am doing it here. Yeah, exactly. In the presentation, just to give you guys an idea, but we can do it also in the code as well. Next, I spoke about generating type-safe wrappers for Substrate events. In order to do this, this is a 2-steps process. We have to, first of all, explore the chain metadata. And this is done through this command, which has 2 parameters, the chain, of course, and the archive. The archive is mostly used to speed up the process. It has an output, which is a big ass JSON file because all of the metadata is binary and it's like very, very big. Gonna make changes to the configuration file because, well, I'm gonna show you why, but basically it's set for the Kusama chain and not the Moon River one. And finally, we need to, well, use the config file to actually generate the wrappers. So let's go. Oops, copied the wrong thing in here. It's basically retracing the history of the blockchain and looking at how many versions there have been, and it's saving the metadata for each of these versions. We can take a look at the file when it's done. Just out of curiosity, there's nothing very interesting to see there, but Meanwhile, I'm going to start copy. Oh, I'm going to start changing the JSON file, which is this one. As you can see, it is set for using a different different JSON metadata JSON file, and it's using a different types bundle. But we're going to just paste it because it's easier. The metadata exploration is done, and this is what it does essentially. It's looking at the spec version where it starts, the hash of the block where the change happened. In this case, I think it's the first one, and then it has metadata field, which is, like I said, ginormous. So this file can be pretty heavy on the on the hard disk. I don't know how big it is, but like we can see it in here. But just to launch the generation of types, we do this, and we're gonna have a different we're gonna have different events defined in here. The name of the event hasn't changed because we were still interested in indexing the balances.transfer. What it has changed is that Kusama and Moonriver, actually, I misspoke. It's not Moonsama, it's Moonriver for this specific project, but it doesn't change. It has different points in history where a change to this event has happened. So the content of this class has changed. First of all, it only has 2, not 3 different ways to decode information out of the event. But yeah, this is the end result.
This is awesome. And you know what this reminds me of?
Mm-hmm.
It reminds me of like the XCM versioning, where each time, the XCM is upgraded, right? You can interpret it differently, V0, V2, V3. And so regardless of which version you're on, everything's going to work seamlessly.
Yeah, I mean, I have to admit, I'm not super familiar with the XCM. It's something that we are exploring right now in Subsquid, so I haven't not been exposed. You mentioned I've been into blockchain, but since 2017, but it was on the surface. I became an actual sort of developer of blockchain only like last year. So
no, XCM is brand new. XCM is like
I mean, I know what it is,
edge.
but but not at that level of detail. So it's super interesting to know. I mean, you learn every day, and that's why I'm loving all of this this environment. I mentioned earlier we need to basically do the same that we just did for Substrate, but for EVM logs. And we know for certain because, I mean, I can show real quick how I did my research. Let me grab this. We want to explore specifically this ERC721 token. It's the MSAMA one, which has a total supply of 1,000, and it's identified with this address. Somewhere in here, I think it was specifically said that it was a ERC721, but also, yeah, you have the contract tab. Now, on the spot, I do remember seeing, maybe you know more than me, that you can download the ABI from here, which could come in super handy actually for doing this, what I'm about to show. But yeah, go ahead.
You should be able to, but that contract didn't look like it was verified.
Yeah, so it should be in this tab, right? Essentially.
I think so, yeah.
Yeah, I mean, I definitely remember doing it because I was looking into, changing to an ERC 1155 or whatever, but it doesn't matter. Like, we decided for this specific example to look into this. We know for certain that it's an ERC 721, so that's what we're going to do. I cheated. I have it somewhere in here, and this is what it is. So I'm gonna, oops, where did I break the, oh no. Yep. Okay. Almost broke the presentation. What I am going to do here is we need to import the ABI in our project. And to be tidy, I decided to create a folder in here, which is going to be ABI, and create a JSON file in here named, well, ERC 71. This one. This is basically the same that I showed earlier in the presentation. We can see that it has the transfer function, and this is what we are interested in indexing. Now, the EVM typegen functionality is pretty simple. It doesn't need the metadata exploration. It just looks at the JSON file and spits out a TypeScript file, which contains interfaces and, like I showed earlier, mappings to decode them. It's not selective, but we'll see it in a second. I think it's better to show it in practice. What I meant by it's not selective is that contrary to the typegen, where I can specify only the events that I'm interested in the ERC 721, the result is it had created interfaces and decoding mappings for all of the events contained in it. So we have approval, even if we're not necessarily interested in it, and approval for all, and our near and dear transfer. This is what we're gonna use. It's still in like being improved. What I suggest is maybe we can turn this string into a constant, so we don't have to repeat it elsewhere. It poses challenges because of TypeScript typing. I tried to do it myself and I couldn't, but I'm a bit of a noob. So we're working on it essentially. But at least it's there. Now, what we can do next, let's see. Oh yeah, I have this stuff because it became a nuisance for me. He was complaining about a lot of stuff that, like I said, it's still in progress, and so the auto-generated code that does not fully comply with the linter. And so in order to not be annoyed by it, yeah, there it is. I added this in here. Okay, should be better. Now, next thing we can do is in order to treat the contract properly, I am going to create a sort of like a file containing a few helper functions that are necessary, well, like the title says, to handle the contract. We need to do some, I wouldn't say boilerplate code, but we need to, well, create the contract itself, create the entity on the database, and like this is a getter function that assesses if the contract exists or not. Let's copy init and paste it in here. And actually, yeah. There it is. Let's see. Yeah, this is one of the annoying bits that I was talking about. I don't know why it didn't pick up the changes in the ERC ES-linked, but I don't know. I'm gonna go rogue and do it for the entire file so it doesn't bother me. Apologies for all of the strict devs out there. And now we're finally into the sort of like the crunch time. We are in the stretch because we are finally going to take a look at the processor logic. I think it's better if I copy paste it and go through some of the changes necessary. But maybe let's start with what we have so far. I think it's better to look at it right now and look at it later. Let's close this one. There's a few errors because we don't have the entity anymore. But what it was doing before, we were instantiating the class. That this is the main. Is basically the protagonist of the project. The substrate processor is responsible for starting with the initial block if we don't set it otherwise. Ingest a certain number of blocks per batch This is what I was discussing with the performance improvements that we have. And you can attach handler functions to it once you instantiate it. What this will do is it's almost like a publish subscribe paradigm. For those who are familiar with it, I essentially tell the processor I want to subscribe to all of the balances.transfer events, and when they are encountered, please trigger this callback function. In this case, it's an arrow function, but we will see how to, like, it's easy just to like extrapolate this as an external function and basically call the function instead of declaring it on the spot. What the function itself does is pretty simple. We have a method to extract the information from the event, which I'm going to show you in a second. And then it's basically putting the right information on the right place and do some basic calculations. Essentially, we try and see if an account with the correct address already exists. If not, we create it, and then we basically do some basic calculation about the balance. If there isn't one, we initialize it. We just subtract the transferred amount minus the tip and save it again. It's relatively simple, obviously, but the purpose of this is to show the capabilities of it. You can definitely do a lot more complex stuff with this. And just to show you the get transfer event, which is used up in here, what it does is it leverages the helper functions that I showed you earlier to assess if the event encountered at the specific block that we are right now is of the right version and extract it with the correct encoding. Like I said, this is all red now because we have changed the event, so it doesn't find the right function. Essentially, when I paste this code, is gonna complain less, I hope. So actually, let's do it, and I think I can show you what I mean. Okay, so one of the key changes that we introduced, instead of having the substrate processor, now we have a substrate EVM processor. This is the one that adds the capability to observe EVM logs, and that's why we can attach an EVM log handler, not just an event handler like before. We have basically added this part right here, which is the ERC721 bit. REST is unchanged. Oh, I forgot to mention, but you can also add pre and post block hooks, which are in charge of, well, as the name says, they are being triggered, like the function passed as an argument is going to get triggered when the block is encountered. And pre-hook means that this is getting called before anything else. So as soon as the block is encountered, the pre-hook functions are called. Then I think we have the extrinsics, then the events, then at the same time the EVM log, because at the end of the day, the EVM log is an event of a specific type. And finally, the post hook. This is what I was mentioning before, where you don't have to use the arrow functions. You can declare a function otherwise and just pass it as an argument. Onto the EVM log handler. The events and extrinsic handler are a little bit easier in the sense that they take as an argument the event or extrinsic name. The EVM log handler takes in the address that you're interested in. And we can see it here. This is the exact address I was showing you before. Is B65 something something, B65 something something, and it going back. You can also filter by this specific event. So, for example, in our case, we're not interested in every event from the ERC 721 ABI, we're only interested in transfer. So we can further filter essentially the execution of the past function. This has pretty much remained the same. Same thing. The only difference is we have an owner entity, not an account, but the calculations are the same. This is the new stuff, and maybe more interesting, just because it's new. We are using the imported mapping defined in the generated, oh, I lost it, in the automatically generated wrapper. So we're using this guy, which is a mapping. So it's a dictionary. Given a certain key, I have access to an object, and in the object, I have further keys. So what I want to do here is I want to extrapolate or decode the transfers event and use the decode function defined in it. Yeah, I added a console log earlier today just because I wanted to make sure that the two worked well together. But the idea is similar to what we were doing above. When there's a transfer, we change we instantiate the owner, we initialize the balance, but most importantly, we create the token entity and store the information of the token itself. This is just a helper function that maybe I should show you down below, but it's doing the same logic as we have here. So it's trying to get it. If we couldn't find it, we create a new one, and then we initialize it with some information. Finally, saves it, saves the transfers as well. Yeah, this is the get or create function I was mentioning before. It became such a cookie cutter function that we are thinking of incorporating it in our code base. So like many projects actually saw this in the template, and pretty much everyone is using it because it's quite convenient. So we're thinking about adding it to the base utility functions that we have. Let's see what's next. I think it's the database. Yep. Like I mentioned, every project has its own database. Like it comes with it. We have a Docker Compose file, and we need to launch it. The Docker Compose, it's just a Postgres image, by the way. It's a Postgres image because we choose so, but I think that the type ORM abstraction layer can handle other databases. I don't see it here. Maybe it's in the models. Definitely in the models, yes. Yeah, this is the abstraction layer that we use. Not necessarily interesting, but since I mentioned it. And let's spin up the Postgres. Oh yeah, I actually have something running, I think, because I was. Yeah. They share the same port, so it was complaining. Okie doke. Let's try again. Yeah. I forgot to launch it as a daemon, so it's gonna. It was going to lock the terminal. I should probably update the presentation with it. Otherwise, people are gonna have their terminal or console window locked up. It's not nice. Finally, we build the code clearly, right? We want to build it and do the necessary changes to the database. Now, this is I'm not playing nice here because it's such a rupture from the previous project that I am deleting the migrations because the project was already like a finished one, the template comes in that way. It has pre-existing migrations, and I'm gonna drop the database and create a new one. Usually migrations actually work the opposite. So they are done, they are conceived to be incremental. For example, I started with a schema, then I realized I want another entity, or I want to make a change to an existing one. I just create a new migration, and it's going to create SQL queries to apply those changes to the database. But in this case, we just make ourselves our lives easier this way. And yeah, drop and create. This is the SQD command line interface. It's part of the tooling that we provide. It comes with this package, and it contains a few commands to, well, as you're seeing here, to manage the database, to I think, yeah, like up here somewhere, but the code gen, SQD code gen, this is the command necessary to create the models. Is part of the tooling as well. And we have tools to manage the project deployed in our aquarium. So by command line, you can authenticate and manage your squid. You can just do list your deployed project, kill some, create new ones, look at the logs, because obviously from the web interface it's not possible, or not yet at least. Yeah, and finally, let's create a migration and apply it. What this, whoops, let's see it. It all went well. What this did is it created a new file in here. The name that I provided is just appended to the file. It's for clarity, it's for, I don't know, future reference in case you have multiple. But as you can see, it has SQL queries applied to the database to make sure that the necessary tables are created. And the migrate command actually is just running those queries essentially. So we should be good to go. Let's see. Yep. Nice. I have comments in here, and I'm going to show you what they mean. We have a makefile, which is a set of shortcuts. Now, bear in mind, if you change your project, such as the changes that we've done, obviously they would not work. If I try and do make explore, it will create a Kusama version, and it was going to look at the wrong blockchain. So I would have to go in here, change it. But because the command itself is quite long and hard to remember, it's quite convenient. So instead of, for example, running this one, I can do make process, and it's gonna be much more, much easier to remember. So it's trying to see if there's any migrations pending, but then it starts to explore the chain. We, by the way, like I haven't mentioned, but we do have from Prometheus metrics that are visible or are available. So one can monitor how the the performance of the API itself, and see what is going wrong, what is going well, etc. The last thing to do, going back to the presentation, is launch the GraphQL server. The project comes with a like an embedded GraphQL gateway, which is going to be available at this address. Since the process is blocking, I'm gonna have to launch a new terminal window real quick. There it is. And it's going to tell me that it's available here. So if we look at the, let's see, localhost, there it is. This is basically accessing the data on my database, but obviously there's not much yet because it's only going through the initial blocks. I found recently that it's a little bit slow because well, there's a lot of data on Moonriver blockchain. When I only had the ERC 721 part, so only this bit, it was going much faster because obviously there was a lot less data, but apparently there's quite a few transfers in here. So that's what sort of like slowing the ingestion. But the difference is that it's slow only because it's applying my business logic. It's not, it doesn't have to index the chain itself. So what I mean by slow is that I don't have the results quickly at hand. It's probably going to take a couple of hours to fully index the blockchain. But in terms of development time, I think that going from a few days to a couple of hours is still a massive gain. When we launch a new archive, the ingestion time, like the time it takes to index all of the blockchain data, it's pretty much around a few days. As you can see, it made a big leap from 0 to 23%. Usually it doesn't do those leaps. I don't know. It has to do with the structure of the chain itself.
Sure. And it could be that, when Moonriver first started, there was like a governance, like a period where we had, pseudo enabled before it was, decentralized. And so maybe there weren't many transfers weren't enabled, for like a month or so. So it could be that jump.
That may very well be exactly. What I noticed in fact is when I didn't have the transfers, it was jumping from 0 to 32%, which is around when the first ERC 721 transfer comes in. But without having to stare at the screen waiting for this to sync, as I mentioned earlier, first of all, when we launched the project, good news, there's actually already an EVM template. You don't have to start from scratch every time applying the necessary changes to say swap the substrate processor with the substrate EVM processor. So that's already like jump ahead. And also this very project, I published it today in the aquarium and we have it open here. It's the same schema, the same interface as the one I have in the playground. It's only like a bit nicer because we styled it up a little bit. But let's do, I think, as you can see, I launched it, I think, a couple of hours earlier. It's taking longer than expected. When I launched it this morning locally, it got to, I think, 40%. I don't know what's taking longer. I was expecting that being hosted, it would take less time. But it was pretty much last minute, so it's a bit of my own fault.
No problem. You mind zooming in just a little bit?
Oh yeah, I forgot.
Thank you.
It's nice to have a 4K screen, but then when you stream it. So yeah, what is happening here? I'm querying for all of the transfers, which are the ERC 721 transfers, and the owners. Because the owners entity is actually shared by the ERC 721 transfers and the like pure substrate balance transfers, we have the first one and not the second one. That's because, like I said, I think it's syncing, it's getting there to the point where it will encounter ERC 721, but not, but it hasn't yet. So that's why it doesn't have any transfer here. I think maybe like by tonight, later tonight, you will be able to play with it.
And everybody should check this out, tomorrow, and or you'll come back to it, right? And there's other projects in the aquarium, to
oh yeah, absolutely. Well. Let me just show you what I mean by the aquarium. This is a list of published projects that we have. You correctly told us to give nice icons in here, and they're coming. I think that's because this one is the one I created. So
it looks great with the substrate EVM one. So
yeah. And yeah, there's this is the example that people can find in the documentation. So just if they want to take a look at it, the very template itself is here, and I'm probably going to add the EVM template, which is kind of like a reduced version of this. It doesn't have the substrate event; it only has the ERC721. But coming in the coming future, part of my job is actually to create some of this. I have an Astar EVM in progress. There's this one is actually from Coda.guys. They're pretty awesome people. One of our warmest partners, and I think this is the project that I was mentioning earlier. These guys are building on Osama. I think. Oh no, actually they are on Astar. My bad. I got confused. But this guy told us that he was able to develop the API in a day. I was pretty surprised. We didn't even know they were building with us.
That's very cool. Massimo, I this has been a fantastic workshop. I hate to say it that we're sort of towards kind of the running out of time.
Yeah.
If you have, is this your last slide? Or was there anything else?
Yeah. There was only I wanted to mention what's next, what people can do. I barely, briefly touched upon it. If you want to do other types of explorations, you can do it by sourcing data for yourself. Where you can start with the Moonscam site, where you can look at other contracts. What to do in the example itself, you can just change the chain node if you want to go to Moonbeam instead of Moonriver, and make the necessary changes to the set data source. Whatever other things that you want to do is, I don't know, you want to monitor ERC 1155, like I mentioned, just change the API and you're good to go, and change the events itself as well. You don't want to look at transfer, you want to look at approvals. That's the idea. And I think finally, yeah, just thank you for having us once again. It was awesome to be part of this. And this is the project. Just leave a star if you like it.
Absolutely, I will. Massimo, thank you so much for joining us today. It was very thorough and very in-depth, and you started with this wonderful introduction, and just absolutely fantastic. We can't thank you enough.
Thank you once again for having us. One of the things that I really appreciate with the .sam environment is how collaborative it is. It's amazing how just people come together and elevate each other. It's really good.
It is wonderful. I haven't seen a community like it before.
Absolutely. Looking forward to seeing more of this and possibly have other events with you guys.
Absolutely. Thank you so much, Massimo.
Thank you.
Until next time.
Till next time. Bye-bye.